This next session, we've got three speakers, as you can see up there. We've got Nathan Sharp on the stage here from Space East, Andy Shaw from Assimilia, and Tom Moxon from Oxwillow. And Space East is only a couple of years old and brought together by Norfolk and Suffolk County Councils just to try and understand what we can get out of utilising the satellite technology in space that we haven't been. So we wanted to discover what we can do in agriculture by using space. GPS has obviously been around for a little while now, but hopefully this is taking us a little bit more in depth. So I will pass over to you, Nathan. Thank you very much.
Thank you very much. Welcome to everyone. My name's Nathan Sharp. I am operations executive at Space East. So I'm very lucky to be supported by two of our cluster members today, Andy Shaw from Assimilia and Tom Moxon from Oxwillow. If you find any of the conversations that we have today interesting, we're on table 49, just over there on the right, left-hand side. So follow up with any conversations you want to have with us there. So you might be wondering, what is Space East and why are we here? So I'll very quickly go through that. So we're currently at 330 cluster members. So what we do is we bring together businesses in both, the private, public and academia, and we bring these together in different industries to look at space capabilities in the East. So currently we cover the 6 counties of Norfolk, Suffolk, Essex, Cambridgeshire, Hertfordshire and Bedfordshire. And we do lots of work. So I'm report to our regional director, Stuart Catchpole. So we've made over 400 introductions in these 2 years. We've got 95 networking events under our belt. And one of the funded projects we should probably just mention is the Quantum Optical Discovery Lab that we're creating at Adastral Park, which is in collaboration with the University of Suffolk. Be one of the largest quantum optical labs in Europe. So it's a really big, important project, that. So this just gives you a little bit of a context about what we do over the region. It's quite a large area. As you can see, we work with big primes in the space industry, Airbus, BAE Systems, Leonardo, Teledyne, just to name a few. And so if you're interested about space, this is the sort of thing we have done in the past. So we had an event at UEA looking at Earth observation. So EO is going to get mentioned probably quite a lot today. EO is Earth observation. So it's basically, what do satellites see looking down at the Earth? And finally, our website. So if you find anything interesting, you want to learn more about space, you want to sign up to be a cluster member like Andy and Tom, if you go on our website, there's a blue box down the bottom. It's very simple, just a couple of bits of information you need to fill in. And then you'll get our newsletters, invites to events and bits and pieces like that. So without further ado, I'm going to hand over to Andy from Assimilia, who's going to give you lots of very interesting information. Yes.
Right, hi everyone. It's very strange, isn't it? A silent seminar. I thought I was going to do hand signals to tell you about satellites. So my name's Andy. Thank you, Nathan, for inviting me. We met just about a month ago at the previous event. We're an Earth observation science and research company based in Reading. So we're not actually in the East, so I'm an interloper. But we've been kindly brought along because we have a very broad knowledge of the different types of satellite Earth observation data sets you can work with. We're 13 people based on the university campus. We work with the likes of the European Space Agency, the European Centre for Medium Range Weather Forecasting and the like. Now, I'm not going to give you a chapter and verse on Earth observation today because there's too much. It's a very broad subject. And as I'm learning, landscapes and adaptive landscapes and agriculture are broad topics as well. So we can't cover everything now. What I'm going to try and do is give you quickly what I think some of the challenges are, some of the projects we're working on, and hopefully that'll whet your appetite to come and speak to us on the stand later on. So I'm going to start my thing so I don't spend all our time. I guess we all know this, that the challenge for modern farming and landscape management is so diverse now. I really feel for our farmers trying to produce food efficiently and profitably while also sequestering carbon, meeting net zero targets, reducing our greenhouse gas emissions, looking after biodiversity, reducing our impact on watercourses, etc., etc. So we're trying to think about how we can produce data sets and models that can inform as much of that as possible in a holistic manner. Our approach to that is not just to use Earth observation. So Earth observation being looking from above remote sensing, either from a space platform or a high altitude platform or an aircraft. But of course, once you take a measurement, one, it's already historic and it's already limited in time and space. Now, if you were trying to forecast the weather, which of course in the UK we love talking about, you wouldn't just look at observations of the clouds. You would use lots of different types of observations, but then you'd put them all into a model. You'd spin up your model and you would run that model forward or backwards, whichever way you want to produce the kind of outputs you want. And modern weather forecasting assimilates more than 200 types of satellite data. Now, for the land surface and adaptive landscapes, we're not quite there yet, but that's the approach that we want to take. What are the models that we're working on? What is it we're trying to understand? What processes are we trying to understand? And then which data sets can give us a little bit of information that helps the model become more accurate? And then once you run a model, you can run it in very scalably, maybe from a field to a farm to a county scale. You can run it through time, forwards or backwards. So with a model, you can make predictions in a way that you can't just with observations. Now, that takes a lot of science, which is why we work with lots of different science partners, such as University College London, Oxford University, Durham and others, as we understand different components of that. And I'm now going to show you some examples of how we've deployed this in reality. So the first one is a project called Nitrogen Use Efficiency, and we're developing a framework for better use of our nitrogen-based fertilizers with a bunch of partners. You can see them along the bottom there. They include Lincoln University, led by ag analysts, and the likes of Dyson Farming, Velcourt, and others are working with us. And here it's about, again, linking together lots of different data sets where Earth observation is just one component, modeling what the inputs to our fields are in terms of nitrogen use, how that impacts both yield and production, but also the impacts on greenhouse gas emissions and others. And so far, we've had 2 years of trials where by bringing this data together, we're able to advise the farmers about putting the right amount of nitrogen in the right place at the right time in the right amount. And here's some statistics about some of the benefits that this project has already delivered. It's a 4-year project funded by DEFRA and the UK. So we're already starting to see a margin over nitrogen. So there is a financial benefit to the farmers of about £18 per hectare on average. Not all farms receive the same benefit. We've got a distribution. Some are not net positive, but most are. And overall, if we applied that to the whole of the UK's wheat growing area, we could save farmers something like £29 million worth of fertiliser cost. Now, if you're from the fertiliser industry, that might not be something you like to hear, but unfortunately that's the way we've got to go. Now, of course, the environmental benefit of that is the reduced greenhouse gas emissions because fertilizers are a high energy intensive production, and also the benefits to less nitrogen pollution in our waterways. And you can see here some of the groups that one of our partners, EFFP, are working on to then work with other stakeholders who could benefit from this kind of approach, like Oxbury Bank, who have a working capital transition facility where you can get beneficial loan rates if you use this kind of approach. So I'd love to spend more time telling you about it, but if you are interested in this, if you're a farmer or a water utility or someone, there is time to become a partner. So the website is there. Snap a photo now if you're interested, and you've got a few weeks still to sign up for this year's trials. As you can see, we've got quite a number of farms participating in the East Anglia region already. So we'd love to add you to that. So that's one thing. So using our data and models to inform how we better apply inputs to our landscape. A second project I want to mention is we've started some work funded by the European Space Agency about nature finance. And in here, there's lots of, I've already heard this today, the 2 talks I've already heard today have talked about, we're at that interface of meeting, well, we should do it for our own needs, shouldn't we, our own purposes, to improve our nature, improve our environment. But we have to meet policy goals, but we also need this flow of finance, blended or otherwise. So what are the metrics of biodiversity that we can develop using this kind of technology to inform that flow of finance. And as you can appreciate, the financial landscape is also very diverse. It's insurance, it's banking, it's lending, it's asset management. So we're taking a top-level approach with this funding to look at where in that system can Earth observation and related modelling tools make an impact. We've got 6 pilots ongoing. The one I want to draw your attention to is number 4, led by friends at University of Oxford, Professor Joseph Bull and his team. How do we define what a metric of biodiversity is that Earth observation can inform? Carbon as a metric, a tons of CO2 equivalent, but we don't know that there's a fungible metric yet for biodiversity that's equivalent. How do you compare, arthropods with vegetation, flora and fauna? There isn't yet that metric. But we can do something, and what the approach taken is to link Earth observation data, which of course is extensive and available through time anywhere, and link that to the kind of species observation data that I think I've already heard mentioned today, and that's becoming more and more available as more and more groups start taking seriously the need to measure and observe out there in the environment. And using AI and these kind of newfangled AI tools. I'm not the world's biggest fan of AI because I think it's sometimes overblown in what it can achieve. We do need data to inform the training of these models. So we're doing this work at the moment in Holland with Friesland Campina, one of the largest dairy operators in the Holland, and I think this might translate well to your environment here, similar kind of fenland, lowland environment. So this is a call to say, if you're interested in that part of the science, if you've got data to offer that we could work with, or you're interested in the methodologies, do come and talk to me and we can get you involved. There's a lot more there to say, but I'll move on. Carbon. I just want to say a couple of things about carbon, because at the conference I was at a month ago, I made quite a strong statement. If anyone comes to you and says, I can see your carbon from space, I would say, sorry, don't believe them. It's not true. There's a lot of overblown promises being made. Yes, you can see trees. Yes, you can see the dynamics of land management as we plant, things grow, we harvest, some remains in the ground, cover crops, minimum till. All these kind of things are there that will affect the amount of carbon and the quality of the carbon in our soils or in above ground carbon. So we would say, be very careful when people say, I can promise you this very easily. I think it's very uncertain, the science. But that's not to say we can't do something. Now, on above ground carbon, I would say certainly look at what people like ArcZero, John Gilliland and his team are doing with airborne LiDAR. LiDAR is a fantastic tool. It's the use of light measurement from above. It gives you very accurate height estimates of tree canopies. It's been used by the likes of the UK Centre for Ecology to create this map of all our hedgerows and boundaries. So, heights and widths of hedgerows, which is a kind of approach towards saying, well, how much carbon is actually in those landscape features. So I would say there is satellite data we can use, and I haven't got time to tell you about all the new things coming. I was just telling some new friends here about the new biomass satellite, which is a radar imaging satellite. But I have to stop because I will be here all day otherwise. But yeah, but remember, it's about a model that says, well, what would you expect to see? How can the observation confirm or deny what you think you're seeing? Now, in terms of soil carbon modeling, even more important to have a model, because it's a dynamic system. And you need in situ measurements. You can't just rely on a remote sensing observation. So there are projects out there that are looking at how do we model the dynamics of soil carbon. So Rothamsted have got a carbon model called ROTH-C. The European Space Agency have run a program in Holland with Wageningen, assimilating Earth observation data about green cover and how that changes through time. And then within the model, how would that affect the sort of the volume, the biomass volume in the soil going forward. Now, I can tell you now, because I'm talking to the Space Agency, they're interested in bringing that technique to the UK and testing that in the UK environment. So if anyone's interested in joining a consortium to test those methods in the UK, be very interested to speak to you. I didn't check before I came quite how much peatland you've got here, but I know there is a lot, and I've been very modified over the years. Now, peatland is something we're working a lot on right now with partners from University of Leicester, KU Leuven in Belgium, and this is about the extent and condition of peatlands. And this starts bringing in other techniques where we look not just at the vegetation, but the thermal environment. So a peatland is generally a humid, cool environment, and it should look thermally different from the land around it. So that brings in the idea of thermal data, which is not something that people talk a lot about. But if you the model will say, well, I imagine the peatland, a healthy peatland looking like this, and you should look in the thermal as part of that. Soil moisture, water table, and that kind of thing is also in there. So again, we bring all those techniques together into that project. I've run out of time, so I was going to talk about water quality because I chair a group called AquaWatch UK Australia, working with the Australians, developing digital twins. And we also use thermal data to run pest risk modeling in Africa. But that is just to give you a flavor of the kind of things you can use Earth observation for: thermal, optical, radar, LiDAR, lots of different data sets, lots of different applications. To find out more, come and talk to us on stand 49. All right, thank you very much for your attention.
Thank you, Andy. And now Tom from Oxwillow.
Thank you very much, Andy. And also thank you to Nathan for having me along. So, yeah, morning all. I'm just here to give you a very high-level overview of what Oxwillow are doing on farm. I'm just going to quickly introduce myself. I'm Tom Moxon. I'm the Supply Chain Sustainability Lead at Oxwillow. And, well, we'll start with our mission. So our mission is to do well for nature, for climate, and for farmers. And you might all think, well, how are we going to do this? I think Dan actually put it really well earlier that nature is synonymous with resilience, and that is something that we are trying to build within the agri-food system. We're trying to integrate carbon accounting, biodiversity net gain, and sustainable farming practices all within the agri-food system to enhance that resilience and add that resilience in. We are based just outside of Ely, and we are adjacent to the Ouse washers. We are adjacent to the SSI Ramsar site, which places us in a high priority area, which is a key area for landscape restoration and recovery, which is something that we are extremely interested in. The area was sort of drained approximately 350 years ago, and the region has suffered significantly with biodiversity loss, which has been noticed by farmers all across the area. We're therefore working across numerous projects surrounding biodiversity net gain and landscape recovery to bring this back to the area and revitalise that. So what tech are we actually using on farm, you might be asking? Well, we're using AMI stations to monitor insects and moths. They sort of beam up a light on a whiteboard within the field. Then these insects and moths land on that. We take high resolution images of them, and we're able to classify that and quantify that data. We're also using peat cameras and subsoil monitoring. We're listening to earthworms to analyse our sort of peat health and how that peatland is doing. And we're also using LoRaWAN, which is a hydrological monitoring, along with flux towers to look at eddy covariance. So we're looking at that gas flux in and out of the field, monitoring different crops and that the carbon that's fluxing between them. And where are we exploring Earth observation? I think that's the most important part here. It's what Nathan's brought me along to talk about today. So we're looking to identify areas within our landscape recovery, within our biodiversity net gain, where we can utilise Earth observation. We're looking at high altitude platform systems. Can we use high resolution imagery? Can we use things like that thermal peat monitoring? Can we look at the peat to see how our restoration of that landscape is actually impacting, sorry, these headphones are really distracting, at how what we're doing with our landscape recovery is actually impacting that land. Is that peat health improving? We're also looking at implementing satellite observation using the typical high resolution imagery, using imagery from drones as well to sort of focus right in on that vegetation, and can we get a closer to the ground look at what we're doing, how that's impacting peat, and whether we are in fact protecting that land. I think that's all I've got time for, so thank you ever so much. I'm Tom Moxon. If you want to come and chat to me, I'll be over at stand 49. Cheers.